So slope in and of itself is a really simple concept. But it's most commonly mixed up. I think of any simple math concept is the one that's most easily mixed up.
Oh, Mr. Dear Mr. President. I swear. What happened? What is this? You saw you can't get it together, man. Thank you, Mr. President.
Alright. Slope, change in y over the change in x. Okay? I think his most common mistake is getting it flipped upside down. So you just have to make it extra crystal clear in your mind. Rise over run. Okay? Change in y over the change in x. Now, more importantly, is when we start moving into applications, interpreting word problems, interpreting equations, slope is also referred to as rate of change. Okay? So they're synonymous. Slope describes a rate of change. In a linear equation, it's constant. It's the same throughout. When we move into applications or into other types of equations, then we won't necessarily have a constant rate of change. And then we can talk about average rate of change over a certain period. Okay? The order that you have your points in doesn't matter, as long as the first two numbers come from the same ordered pair. Okay? So whatever point you delineate as point 1, whichever one you delineate as point 2, it does not matter as long as the first two numbers come from the same ordered pair, and then you'll end up with the same answer, regardless of what order you do your subtraction. So we're given 2 points. We want to find the slope. We need to use our slope formula. y2 minus y1, x2 minus x1. Okay? What are the y values of my ordered pairs? What are the y values of my ordered pairs? 9 and negative 5. Okay? You could do 9 minus negative 5, or you could do negative 5 minus 9. Either way, it doesn't matter. If I have the 9 first, what x value do I need first? What x value matches up with the 9?
Negative 6.
Negative 6. So if I do 9 minus negative 5, I have to do negative 6 minus 3. 9 and negative 6 come from the same point. Negative 5 and 3 come from the same point. If I switch the order, then I need to switch the order. But either way, you'll end up with the same answer. Okay? What is 9 minus negative 5? Positive 14. And then negative 6 minus 3. Negative 9. If you did the bottom, you get negative 14 over positive 9, but both of those end up being the same equivalent fraction of negative 14/9. Slope. Fractions. Always simplify your fractions. Always, 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 always simplify your fractions. Okay? No matter what, simplify your fractions. I think that was probably the most common question asked so far today on the homework. Why is this wrong? You didn't simplify your fraction. Simplify your fraction. Okay? 14/9 can't be, so we leave it alone. Alright? Now, we talked yesterday about horizontal and vertical lines with our x equals a constant and our y equals a constant. Okay? With those two numbers. We want to find the slope of those lines. So I can pick any 2 points on my line. I can use my slope formula. y2 minus y1, x2 minus x1. What are the y values of my 2 points that were chosen? Negative 3 and negative 3. Negative 3 minus negative 3. 2 minus 0. I get 0 over 2, which equals what? What's 0 over 2? 0. Horizontal lines have a slope of 0. Okay? All horizontal lines will have a slope of 0. You can see that mathematically, by picking any 2 points on a line, we will always get that no matter where my horizontal line is. Horizontal lines will always have a slope of 0. Now, when we look at vertical lines, it's going to be a little bit different. Okay? Still pick 2 points. Doesn't matter which ones. Okay? My y values, 3 and 0. My x values are both negative 6. So I'm left with 3 over 0. What's 3 divided by 0? Say it again. Not 0. Undefined. Vertical lines have an undefined slope. Okay? Horizontal lines, slope of 0. Vertical line, undefined slope. Yes, sir.
Is that just because of like what they call it?
So think of it this way. Slope is our rise over our run, right? For every unit that I go to the right, how far up do I go? I go up forever.
Yeah, up forever.
I go up forever. Okay? So their slope is undefined because I will always keep going up before I go to the right. Okay? So our slope is undefined there, but with a slope of 0 for every unit right, I don't go up at all. So on a horizontal line, I have a slope of 0 because I go up 0 and I go over 1. Okay? But when I'm looking at my vertical line, trying to go up, well, I never stop going up. I don't even get a chance to go over. Okay? Alright, so that's just a recap on our horizontal vertical lines. Horizontal lines are y equals a number, a constant. They're going to have a slope of 0, horizontal line. They're going to intersect the y-axis, but not the x. So they'll have a y-intercept, but no x-intercept. And then our vertical lines are the opposite. X equals a constant. We'll have an x-intercept, but no y-intercept. We'll have an undefined slope. Now, find the slope of the graph of that equation. So I don't have 2 points, so I can't plug it into my slope formula. But luckily, we have a form of a linear equation that lets us have the slope. What form of a linear equation tells me my slope? Y equals mx plus b, also known as our slope-intercept form. So slope, intercept, y equals mx plus b. What part of that equation gives me my slope?
3x. Oh, wait.
Well, that's not in slope-intercept form yet. So if I have y equals mx plus b, what part gives me my slope? M. Okay? M is my slope. What does b tell me?
Y-intercepts.
Okay? Tells me the y-intercept. More specifically, the y value of the y-intercept. Because remember, your y-intercept is always going to be an ordered pair. So it gives you the y value of the y-intercept, and all y-intercepts have what x value? 0. Okay? So we need to get that in slope-intercept form. Solve for y. How do I get y by itself? Subtract 3x. And then divide by 4. So what's my slope? Negative 3/4. What's my y-intercept? 0 9/4. Ordered pair. Ordered pair. Now, generally, when we're dealing with slope and intercepts, okay, slope-intercept form, sometimes you might be tempted to turn that intercept into a decimal. Never mix fractions and decimals in the same equation. Okay, if you have slope as a fraction, which is the easiest way to model slope, then you need to leave your y-intercept as a fraction as well. I don't ever want to see negative 3/4 as the slope and then 2.25 as the y-intercept. Okay, don't ever mix fractions and decimals in the same equation. Always keep it consistent. Graph a line that passes through the given point and has a slope of 1/2. Ignore the blue line on the bottom. Alright, so the given point, -3, -2. What quadrant is that located in? Third. Third quadrant. We got 1, 2, oopsies, go back. 1, 2, 3, 4. Okay, so I got -3, -2. And I have a slope of 1/2. So how do I get to the next point using that slope? Up 1, right 2. Rise over run. I'll rise 1 and run 2. So up 1 over 2, up 1 over 2, up 1 over 2. And I can continue that pattern forever to get my line. Sound effects make it better. Now, parallel lines and perpendicular lines we're going to keep pretty straightforward, okay? We're going to keep it simple, just kind of identifying whether or not they're going to be parallel or perpendicular. So, parallel lines never intersect. Why do they never intersect? What about parallel lines makes it so that the lines never intersect? Okay, what makes them parallel? Same slope, okay? Same slope makes them parallel, so they're never going to intersect. All right? So when I'm looking at two lines, whether I'm given 2 points from 2 different lines, whether I'm given the equations of the lines, what do I have to know about them in order to determine whether or not they're parallel? Their slope. So if I'm given 2 points, how can I find slope? I don't need to grab them. Midpoint tells me the middle. Slope formula. Not trick questions. So on my first ordered pair, there we go. My first set of ordered pairs for my first line, what are my y values? 2 and 5. If I do 2 minus 5, what does the denominator need to be? 2 minus 5 is what? -1 minus 3. Does this simplify? 3 over 4. 2 negatives make a positive. 3 over 4. So if these lines are going to be parallel, what does the other line need to have as a slope? Same thing. 3/4. 10 minus 7. 8 minus 4. 3/4. They're parallel. Parallel lines never intersect. Parallel lines have the same slope. If you're given a formula, here's the slope of those lines. Decide whether they're parallel. If you have equations, what can I do to an equation to figure out the slope? Slope-intercept one. Just look. Perpendicular lines. What do we know about perpendicular lines? They make a 90-degree angle when they intersect. And so the thing about forming that 90-degree angle during intersection is a couple things. One, they have to have opposite slopes. One has to be positive, one has to be negative. It's the only way you're going to get that 90-degree angle. So your slope, one of them will be a positive slope, and the other one will be a negative slope. Okay? So one will have a positive slope, the other will have a negative slope. The other thing is that the slopes have to be reciprocals. They'll have to be reciprocals of each other. What does it mean to have a reciprocal? Opposites when we change the sign, reciprocals when we flip the fraction. So if I have a slope of 3/4, a slope of 3/4, and I want the reciprocal 4/3. And in order to make it perpendicular, I also need it to be the opposite. -4/3. Okay? So if I start with a slope of 3/4, its opposite reciprocal is -4/3. The other thing with our perpendicular slopes is an easy way that we can check. Their product has to be -1. So if I multiply them together, 3/4 times -4/3, -12/12 gives me -1. So if you do a quick multiplication of the products, or multiplication of the two slopes, you get a product of -1, then they're perpendicular. Same thing with parallel lines. We have to know what the slope is. So if we're given 2 points, slope formula. If we're given an equation, slope-intercept form. So we're given an equation, slope-intercept form. Get 3x plus 5y equals 6 in the slope-intercept form. So what's the slope? If the other equation is going to be perpendicular, what does the slope need to be for the other equation? Positive 5/3, because it needs to be opposite and the reciprocal. Okay, so I need to get a slope of positive 5/3. So 5x minus 3y. We'll subtract 5x. Divide by -3. Perpendicular. Slope, perpendicular lines have opposite reciprocal slopes. Now when we get into real world models, we rarely end up with perfect straight lines. So we can use, instead of talking about slope in a model, you won't see slope. Let's talk about like the pitch of a roof. You're going to see average rate of change instead. Average rate of change is just slope. Okay, it's taking a linear form and putting it on a real model. When it asks for average rate of change, it's asking for slope. So here we have 2 data points. Wants us to find the average rate of change and then compare it to the graph here. Okay? The points they give us up here are these 2 points on our graph. So what they're having us do is compare the slope of a small section of the graph as the average rate of change. And it also wants us to find the slope over the entire graph and compare that information. So if I'm using my slope formula for the 2 points up front, what numbers am I going to use for my numerator? Okay, so I'm going to do 843 minus 818 just so that I get the positive number when I subtract. So if I have 843 first, what's my denominator going to be? Okay, so 25 over 1. Knowing that those points came from that graph, 25 over 1, what does that represent? What does that mean? So for every year, okay, 25 what? 25 hours per person. So the amount of TV consumed per hour per person increases by 25 a year, okay, from 2002 to 2003. Okay, so it went up 25 hours per person. Now we want to do the graph. What points are we going to use from the graph? Eight, 7, 6, 9. 8, 6, 8 minus 7, 6, 9 over 2004 minus 2000. $99 over 4. How does that compare to 25 over 1? Okay. Bruce, you want to add to that?
It's less than 25.
Okay. By how much? So if we're comparing them, and we're comparing the rate of change, more or less they're the same. Okay? So the average rate of change over the entire interval, negligible difference. It's pretty consistent throughout. And we can see that the graph looks like it's almost a straight line. Okay? I mean, for all intents and purposes, it looks pretty damn close to a straight line. Okay? So the rate of change is pretty consistent over the time period, and we can see that by calculating it for a small section and for the entire line. Okay, so it's a near constant rate of change. Last thing we're going to look at is we want to find the average rate of change in percent per year. Okay, in percent per year. So I need to figure out if I have 1997, 36.4% of high schoolers, and then in 2003, 21.9% of high schoolers. What are my ordered pairs going to be? What are my X and my Y values going to be? Which one's going to be the X and which one's going to be the Y?
The X will be yours and the Y will be the percent.
Yeah. There's my ordered pairs. Okay? And it's talking about percent per year. Percent per year. And since rate of change is Y's over the X's, percent's going to be our Y values, year's going to be our X values. So we can go ahead and we can set up our rate of change. So that's our slope formula. Okay, 36.4% minus 21.9%. What's that give me? And 1997 minus 2003. Negative 6. Okay, does this give me percent per year? That gives me 14.5% over 6 years. What can I do to find the percent? Go ahead and do that division. 14.5 divided by negative 6 gives me what?
Negative 2.416.
Okay, negative 2.4% per year. Okay, so did the amount of smokers go up or down? It's a negative slope. So as time moves forward, percent goes down 2.4% per year. Okay? Questions, comments, concerns, queries, or conundrums? Rate of change and slope. Same thing. Slope formula, slope-intercept formula, Boolean equation. They represent the same thing.